everyone. I am Dr.P.Santhi, Assistant Professor of Mathematics, the Standard Fireworks Rajaratnam College for Women, Sivagasi. In this video, let us learn about complete metric space in real analysis. The learning objective of this video is to learn what is complete metric space, and also let us see some of its examples, and then finally let us see its applications in real analysis. Okay, these are the three learning objectives of this video. Let us enter into the video. Complete metric space. Complete metric space is nothing but a metric space satisfying an important condition, that is, every Cauchy sequence must be converges. See, we know, well, let us know everybody what is metric space. A metric space is a non-empty set satisfying 4 conditions, isn't it, with the corresponding metric D. The first one is D of x comma y is greater than 0, and if the distance between the 2 points D of x y equal to 0 only if x is equal to y. And then third condition is D of x comma y must be equal to D of y comma x, and finally it must satisfy triangle inequality, that is D of x comma z is less than or equal to D of x comma y plus D of y comma z. So, along with those conditions, if we consider a Cauchy sequence in a complete metric space, if that Cauchy sequence converges to a point in that space, then only we can say that a metric space is a complete metric space. That means Cauchy sequence, for Cauchy sequence, if we consider any 2 points in the sequence, it gets arbitrarily small as n and m tends to infinity. That is, let us see elaborately about Cauchy sequence and convergent sequence. Cauchy sequence is a sequence where the distance between any 2 points in the sequence gets arbitrarily small as the sequence progresses. That means the distance, if we consider 2 points xn and xm in the space, the distance between D of xn comma xm must be less than or equal to 0, arbitrarily small as the sequence progress indicates, as we allow n and m tends to infinity. For convergent sequence, we have considered a sequence in which all the entries in the sequence must approach a specific point, a specific limit L after some stage. Then we can say that a given sequence converges to that limit as n tends to infinity. Alright. So, also we know that the relation between Cauchy sequence and convergent sequences, every convergent sequence is a Cauchy sequence, but Cauchy sequence need not be convergence. Only if all the Cauchy sequence in that space converges to a particular point, then only we can say the space is a complete metric space. Let us see some of the key points for complete metric space. The mathematical definition for complete metric space is, if D of xm comma xn tends to 0 as mn tends to infinity, then there exists x naught in x such that D of xn comma x naught tends to 0 as n tends to infinity. That indicates the sequence xn converges to x naught. Okay, so xn converges to x in in the given metric space capital X. So, from that we can observe another information that the given sequence is converging, then we can observe that it has a convergent subsequence. The given space has a convergent subsequence. Therefore, every Cauchy sequence in a complete metric space converges to a point within a space. Similarly, convergent subsequence, that means every Cauchy sequence in a complete metric space has a convergent subsequence. Next, let us check whether the real line R is a complete metric space or not. So, this is one of the basic example for a complete metric space. Let us consider a real metric space R along with the metric D as a usual metric, that is D of x comma y equal to modulus x minus y for all x and y belongs to R. So, this space real line R along with this usual metric will satisfy all the conditions for complete metric space. That is, if we consider any Cauchy sequence in this metric space, definitely it will converge to a point in R. Hence, we conclude that a real line R is a complete metric space. Yes, we conclude that R is a complete metric space. Let us see some more examples for complete metric space. So, here let us consider the space C set of all complex numbers, okay, as the space of all continuous functions defined on the closed interval 0, 1. Okay. Here we consider X as C as a space in which all the entries are continuous functions defined on the closed interval 0, 1. The metric space x comma d, that is, here we are defining the metric space d as d of f comma g as maximum of modulus of f of x minus g of x. If we define a metric like this, maximum of modulus f of x minus g of x, then this metric along with the given metric space x will form a complete metric space. So, this is another example, and one more example is, if we consider any metric space x along with the discrete metric space, then automatically it will be a complete metric space. What is discrete metric space? A discrete metric space is nothing but it takes only two values 0 and 1, 0 if x equal to y and 1 if x is not equal to y. So, if we considering any space along with the discrete metric space, then every Cauchy sequence in this space will be convergence. Hence, we conclude that this is a complete metric space. Finally, what are its applications in mathematics? The concept of complete metric space is applicable in analysis, topology and functional analysis. The specific application for analysis is to study the convergence of sequences and series, in topology to define the concept of continuity and differentiability. Finally, in functional analysis, it is used to study the convergence of sequences and series in function spaces. Yes. Thank you. Hope you would understand what is complete metric space, what are its examples and its applications. Thank you all.